Okay, so today we're going to learn about the properties of those cosine and sine functions. So we're going to start with the sine function. We're going to answer this question: how long is one cycle of the sine function? Anybody figure it out? 2 pi. That's exactly right. How many of you guys got 2 pi? Okay, good. Hey, let me just show you. If this is the x-axis, the sine function started right here, and it went up, went down, and it came back up like that. I've got to, hold on just a second. Okay, now it should work. Okay, so you'll notice that it went up, down, back up to right here, and now it's ready to start the cycle over again, isn't it? And if I continued that to the right, it would do that. Well, remember that this right here, where it crossed, was pi, and then right here at 2 pi is where it ended, one cycle. Okay, so it went from 0 to 2 pi was one cycle. We call that, in trigonometry, they call that a period. That was one period of time along that cycle. Okay, and it repeats, the period repeats every 2 pi. So where's the second cycle going to start and end at, you guys? It's going to start at 2 pi and end at 4 pi, and then it's going to go till 6 pi, and the next one till 8 pi, right? If I'm going the negative direction, negative 2 pi, negative 4 pi, negative 6 pi. Do we understand that? And you could take a rubber stamp and make a copy of this red right here, and just go along and stamp it, and stamp it, and stamp it, and it would look the same all the way across. And that's what the sine function does. Okay? In other words, from where to where does the function start and end the cycle? And that was 2 pi. Okay. Number 2, what is the domain of the sine function? What do you think? Okay. It is all real numbers, Ramon said. What do you think? Well, let me ask you this, you guys. How far to the right is this function going? Forever. How far left is it going? Does it take on every value in between? Yeah, so it's going to take on every single x value. So the domain is all real numbers. Okay, what is the range? If you know the range, raise your hand. Don't say it out loud, please. I just want to see how many of you think you know the range. All right. Okay. What is it, Sean? Okay. So y is, because y is the range, right? You guys, he's saying it has to be between negative 1 and 1, right? So the range is between negative 1 and 1. You'll notice that the highest this graph ever got was 1, and the lowest this graph ever got was negative 1, and every y value in between was filled in somewhere, several times, actually. Infinite number of times. But that is the domain of the sine function, I mean the range of the sine function. Okay, number 4, where are the x-intercepts located? Every pi, right? So we're starting at 0. You can do it like this. You can say it's at 0, pi, 2 pi, 3 pi, and you can continue the pattern. Dot, 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 and you can go negative pi, negative 2 pi, dot, dot, dot. That means it continues the pattern. So every time it crosses pi, every multiple of pi, then it's going to have an x-intercept. Another way of saying it is multiples of pi. Got it? You'll notice on your graph it crosses the x-axis at 0, then pi, then 2 pi, then 3 pi, and so forth. Okay, where is the y-intercept? Name me the x and y coordinate. 0, comma 0. Yeah, you're looking at the cosine. 0, comma 0 is the y-intercept. Okay, number 6. What is the maximum value of the sine? Oh wait, go back to number 5. I always remember that the sine function starts at 0, 0. When I want to check to see if something's a sine function or cosine function, I go look at where it crosses the y-axis. Do you understand that? Now we're going to learn about horizontal shifts later on and period changes later on, and it might not cross there. And so, but if it hasn't had a shift of any kind, then you know it's a sine function if it goes through 0, 0. Okay, number 6. What is the maximum value of the sine function? We kind of answered that when we answered, what is the range? It's 1, right? The highest, the biggest y value is going to be 1. What's the smallest y value? Okay, so wait, did I answer? What is the maximum value? What does the maximum value? Oh, where does the maximum value take place? This is question number 7. Where is the y value 1? Where's the first one? Look at your graph. Something, comma, 1. Pi over 2. Yeah. Where else? 3 pi over 2? Negative 3 pi over 2? Oh wait, it doesn't happen at 3 pi over 2, does it? Okay, so pi halves, negative 3 pi halves. What do you think the next one to the right is going to be after pi halves, you guys? I think that's 1/2 pi, and that it's going to be a pi halves shifted over from 2 pi, isn't it? Anybody want to say what that is? 2.5 pi? Yeah, and we'd say it like this, 5 pi halves. The next one, what do you think the next one's going to be following this pattern? 9 pi halves. Okay? The way we say this is every other odd pi half. That's how I say it in English. Every other odd pi halves, apostrophe. How's that sound? Every other odd pi halves. Okay, because notice it skipped 3 pi halves. So it's got to be every other one. Okay, question number 8. What is the minimum value, everybody, of the sine function? -1. That's the lowest value it ever gets to. And where does the minimum values take place? What's the first one to the right, going to the right from 0? Come on, help me out, you guys. 3/2 pi is the first one. Well, 3 is not even. It's every other odd pi half starting at 3 pi halves. Okay, so 7 pi halves, 11 pi halves. And if we go in this direction, it's going to be negative pi halves, right? Negative 5 pi halves. What? Well, we're looking at the graph. See, can I borrow yours, Sadie? You guys will notice right here. See this minimum point right here? On the blue one? See the minimum point right here? I can see that the y value is -1. Okay, -1 right there. And so it happens at 3 pi halves. I also see it happens right there at negative pi halves. How do you come across it? We made them last time. Were you not here last time? Okay. Yeah, we made these last time. Someone will have to help you. Okay? All right, we made one for the sine function and the cosine function. Everybody, get your graphing calculator. I'm going to teach you how to graph this into your calculator now. Yeah, that's because we did it in my last class. Okay, just like your graphs are going to all be in here. Okay, everybody, we're going to graph the sine function. Everybody go to y equals and hit sine of x. And then everybody go to your mode button. And what do we want to change this to? Radians, because we're going to change it to be the same as what we just graphed that in. Okay, and now go to your window. You're going to have to set this in a trigonometric window. We're going to set this from negative 2 pi to positive 2 pi. Remember when we did this, I had you go from 0 to 2 pi? But to the left, I only had you go as far as you could reach. But we're going to go from negative 2 pi. So everybody go negative 2 pi. Whoops, that's E. My eyes are bad. I can't even see where pi is. Right there. Okay, and then the x max is at 2 pi. Say that again. The x scale, that is a good point. We went pi 6, but pi 6, let's see. How many marks are there from 0 to 2 pi? How many marks do we have there? 12? That might be all right. Let's do that. Let's go every pi 6. So everybody hit second pi divided by 6 for our scale. Just like we did the scale when we did it by hand, right? We went pi 6, every pi 6. Pi divided by 6. As soon as you hit enter, it changes it to a decimal. But that's how I do it. Now, what do you think my y min and my y max want to be? Yeah, let's just go up to 2 and negative 2, just so we can, negative 2 to 2, just so we have some room to look at it. And what do you want to put the y scale in? Do you want to put it in ones, or do you want to put it in 0.2? Okay, tenths, or every 2 tenths. Okay, hit graph. You should have a nice looking sine graph. Okay, there is the sine function that we graphed by hand the other day. Now, yes. Say that again. Yep, y equals sine of x. Okay, I want to show you guys, we're going to extend this. So I want everybody to go back to your window. Yeah, if you guys are wondering what I put in here, I just put sine x, like that. If you got lost. Okay, everybody go back to your window. Let's change this. Let's go 2 windows to the right. What would that be 2? Let's go 2 cycles to the right and 2 cycles to the left. What's my y, or my x min and max going to be? Okay, negative 4 pi and positive 4 pi. And we're going to up the scale. We're going to go every pi thirds. So pi divided by 3, yes. We went from negative 4 pi to positive 4 pi, because we're going to go 2 cycles on each side of the y-axis. Pi thirds to the x scale. Pi divided by 3. Okay? Now, my y min, we can keep that the same. Y max, all that can stay the same. But now, we're going to see 2 cycles to the right and 2 cycles to the left. You can do as many cycles as you want. So if we trace this, just so you guys can see a period of the sine function, here's 1 period, right? How many periods appear on here? 4 of them, because here's another one. Here's another one going to the left. Another one going to the left. It's a total of 4 periods on there, okay? All right, now, that answers questions about the sine function. On your bell work, I want you to write down what the domain and range of the sine function is for your bell work today, okay? How many bell works do we have left? 1 more after this? So today is Wednesday. We'll turn it in Friday. Okay, now, you guys, I want you to answer these same 8 questions for the cosine function. Some of them are going to be the same answer. You'll find out. Some of them will not, okay? So I'm going to give you a few minutes. We're going to do the same questions for the cosine function. Okay, you guys, let's see how you did on that. Okay, number 1. What's the cycle of a cosine function, you guys? 2 pi again, okay? Number 2, what is the domain of the cosine function? All reals, same as that. What is the range? Same. Where are the x-intercepts located on this one? Every pi halves? Okay, so this would be multiples of pi halves, right? So pi halves, 3 pi halves, 5 pi, multiples of odd pi halves, that's what we should say. Multiple of odd pi halves. Multiples of odd pi halves. Okay, where's the y-intercept on the cosine? 0, 1. What is the maximum of the cosine function, you guys? Huh? 1. Where does the maximum value take place? Where do the maximum values take place? Every other pi. Start all the odd pi halves. Wait, all even pi halves? No, wait. Every even pi, yeah. Even pies. What is the minimum value of the sine function? What is the minimum value, Easton? It's also -1. Where does the minimum value take place on these? Odd pies? So it takes place at odd pies. Is that what you guys came up with? Okay, now. All right, this is the kind of questions you're going to get on your assignment today. Find the sine of 9 pi halves by referring to the graph of the sine function. Okay, now, for example, okay, yeah, I'd probably write these down. Okay, find the sine of 9 pi halves by referring to the sine graph. Let's look right here. Here's a sine graph. 9 pi halves. If I was to count 9 pi halves, okay, here's 9 pi halves is 2 will go into 9, 4 and 1/2 times, right? So it's going to be 4 and 1/2 times. It's going to be just a little bit beyond this. It's going to be pi halves beyond this, right? It's going to be a maximum. See? You got at pi halves and at 5 pi halves and at 9 pi halves is a maximum. Do you see that? So it's going to be a maximum value. So what is the value?
Is this our assignment?
This is like what your assignment's going to be like. Okay? It's up to you. But do you understand the question? If you understand the question, you probably don't need to write it down if you think you're going to remember it. Do you understand what happened right there? So at sine of 9 pi halves, it wants to know what's the y value at sine pi halves. So if you look, here, right here is pi halves. Here's 5 pi halves. And right over here is going to be 9 pi halves. It's going to be a maximum point. Its y value is going to be 1. Does that make sense? What you're going to do is follow the pattern. Now, this is most of the time these are going to be way off the graph, but you already know the pattern because we wrote them down when we were writing down those characteristics. Okay, let's go to the next question. Find the sine of 3 pi by referring to the graph of the sine function. We can look at the graph. Here's 1 pi. Here's 2 pi. What's happening at every pi? Yeah, it's crossing the x. There's an x-intercept, so it's going to be 0. Any questions on that? Yeah. Okay, one more time. It wants to know, the question wants to know a sine of 3 pi, okay? So we're going to look at the graph. Here's 0. Here is pi. Here's 2 pi. And here's 3 pi. It's not even off the graph. And here's 4 pi. What's happening at every pi? It's crossing the x-axis, which means its y value is what? 0, right? This is 0, 0. This is pi, 0, 2 pi, 0, 3 pi, 0, 4 pi, 0. Its y value is 0. Okay, let's look at the next one. Find the values for theta for which sine of theta equals 0. Well, we just kind of answered that, didn't we?
1 pi, 2 pi, 3 pi.
Yeah. Sine of what angles is equal to 0? Well, if I take the sine of this angle, it's 0. The sine of this angle is 0. The sine of this angle is 0. Okay? Sine of any pi, multiple of pi, is going to be 0. Okay? Remember, the x-axis represents the angles, you guys. Okay, Jonathan, what are you doing?
Oh, nothing. I was.
Okay. Find the value of number 4. Graph y equals sine of x for 3 pi, between 3 pi and 5 pi. What do you think it's going to look like between 3 pi and 5 pi? Well, we can go right here to 3 pi right here, right? So it's going to go down, cross at 4 pi, come back down, and end at 5 pi. So it's going to go like this. Okay? Any questions? Listen. Bryce, listen. Number 5, graph y equals cosine of x for x is between 2 pi and 4 pi. It just says graph it. So between 2 pi and 4 pi, well, we can, you guys already know what it looks like between 0 and 2 pi, right? It's going to be that same thing. Does that make sense? All right. There is your assignment.